Hello, Math 157ers. This is Professor D, and I am going to put together a little bit of a lecture on 6.2, just going over some of the attributes of the normal model, but also to incorporate how you can use StatCrunch in there. Your book does not use StatCrunch in their examples, but the PowerPoints that the authors created did. So I'm using these as a guide to talk you through. There is one mistake on the PowerPoint that they put up there, but I'm going to talk about that in this brief lecture. All right, so let's talk about the normal model. All right, so you can use the normal model if the distribution, excuse me, is unimodal, which means it has one mode. Only one value pretty much occurs the most. It's approximately symmetric, so that means if you cut it in half and you flipped one side onto the other, they would look the same. It's approximately bell-shaped, which you can see right here in this example of the diastolic blood pressure and its frequency. You can kind of draw a bell curve over it. And not as important to you, but the normal distribution is also called the Gaussian distribution. All right, so let's talk about the center and spread of a normal distribution. Okay, mu is the mean. It's the number right in the middle. Sigma stands for the standard deviation of a distribution. Okay. So when we talk about populations, we use mu and sigma. And when we're talking about sample data, we're using x bar and s for the mean and standard deviation. So if you look at this example here, these are both normal distributions, but as the red one is taller and skinnier, there's a smaller standard deviation. And as the blue one is shorter and fatter, wider, there's a larger standard deviation. So when we talk about notation in area, N, that means normal distribution, 6, 2, means that the mean is 6 and the standard deviation is equal to 2. So 4 is one standard deviation below, 8 is one standard deviation above, 10 is 2 above, 12 would be 3 above, 2 would be 2 below, and 0 would be 3 below. 3 standard deviations below the mean. Okay. So if we wanted to find the area under that normal curve above that x-axis, because this normal curve never actually touches the x-axis, we need to find the probability that x is less than 4. So we're finding the area to the left of 4, so we need to find the probability that x is less than 4. And since we're dealing with a continuous variable, it's really the probability that x is less than or equal to 4. All right, so I always like it if you yourself draw a rough sketch of this normal curve with the mean and the area that you want to find. For you just use it up here, this would be our rough sketch. You want to label the mean, your standard deviation, and you want to make sure that you're finding the right area. If you're trying to find probability that x is less than or equal to 4, you know that's the area to the left of 4. If you need to find the probability that x is greater than or equal to 4, well, then you're finding this whole area that my mouse is doing. Okay, so you really just want to be careful with that because you don't want to find the wrong thing because you weren't reading carefully. So probability that x is greater than or equal to 4 would be what I'm kind of shading in the yellow. So StatCrunch will make this a lot easier for you. You go to Stat, Calculator's Normal, type in the mean, and choose which way you wanted to go and find the standard deviation. So we are going to go here. I've just clicked on StatCrunch right here. And it's easy enough. If I just click on that just to get into StatCrunch, it'll open StatCrunch over here. I don't need to worry about any of that stuff. So we're going to Stat, Calculators, Normal. Our mean was 6. Our standard deviation is 2. And we want to find the probability that x is less than or equal to 4. and we hit compute. And there it is right there. And it looks just like the example here. So 0.518655 going on. Remember, the area underneath this whole curve is equal to 1. So if I wanted to find the area of x is greater than or equal to 4, it's 0.8413. You can see that's area shaded in red. But kind of the old school way to do it is if you used to have tables that found the area to the left, if I needed the area to the right, I would pull up my calculator, and I think I can actually be really sneaky and copy this. But I'd have to pull up my calculator and do 1 minus, let me see if it'll let me copy to my calculator, 0.841344, which now with new technology like StatCrunch, it actually will calculate that for you. You type the value of x, click compute, and you're done. So here's just a screenshot of what we did. Stat calculator is normal. Put in the mean, you put in the standard deviation. You put what you're looking for, you hit compute, and there it pops it up for you. Now let's look at another example. Research has shown that the mean length of a newborn Pacific Harbor seal is 29.5 inches and that the standard deviation is 1.2. It follows the normal model. Find the probability that a randomly selected pup will be more than 32 inches. So again, always a good idea, if I can find my pen, always a good idea to draw a rough sketch, and that's a really rough sketch, and I'm not using my pen tablet. And it's actually not letting me keep it on here. Well, that's kind of funny. But my rough sketch would be a curve, and then a curve, and then we put our mean in the middle, and we want to do more than 32. So if we go back to StatCrunch, and I already forgot our data values, 29.5 and 1.2. Our mean is 29.5. Our standard deviation is 1.2, and I want to find the probability that x is greater than or equal to 32. Compute. Now, what did I do wrong? If I had drawn my sketch, I would have known that I wanted to actually find the probability that it's greater than or equal to 32. And hit compute. Okay, and that's 0.0186. All right, let's look at the next slide, which is going to go back over that for us. .019. And you just be careful if you're working homework problems that you round to the number of decimal places that it indicates it wants you to round to. Now, finding the probability between two values. If you were to pull up these PowerPoint slides from the multimedia library, it reads differently. I think these slides were written before StatCrunch had the ability to do between. Okay, so we're going to do stat calculators normal, and we're going to change to the top of the screen and do between. So here we're trying to find the probability that x is between 3 and 6. It's a normal curve with mean of 4 and standard deviation of 1. So we have to go to between, mean of 4, standard deviation of 1, and I'm trying to find probability that it's between 3 and 6. And there it just does it for us, 0.8185 or 0.819. Now, one thing StatCrunch won't do for you, and you may not need it in the problems we do in this course, but sometimes you need to find the area in these tails. Okay, so I want to find the probability that x is less than 3, which would be this white area over here, and the probability that x is greater than or equal to 6? Well, we have all the tools because, remember, the area underneath the curve is just equal to 1, and we could do 1 minus this number, and that will give us the area in these little white tails. Okay. Now, how do we find probabilities from percentiles? So newborn seals in the bottom 10th percentile typically don't survive. So we know newborn seals have a mean of 29.5 pounds and a standard deviation of 1.2. How do we find the 10th percentile? Well, you kind of work backwards because we need to find what x corresponds to the 10th percentile. So, what was it, 29.5, standard deviation of 1.2, and we're going to go back to standard. Should have done that first. It doesn't, it seems to be locked. Let's go back to standard. Oh, I am in standard. And what we do is we leave this blank, and we want to find 0.1. And we really need to find the x is less, we need to find this x over here that corresponds to the 10th percentile. So the probability is 0.1, okay? And so seals that weigh less than 29.96 or about 28 pounds typically don't survive because they compromise the bottom 10%. So you just have to be careful here because 10th percentiles typically deal with less than or equal to. So if we want to find seals at the 15th percentile, we put 1.5, compute, and we seals at the 15th percentile weigh less than or equal to 25.26 pounds. Okay. Okay. The empirical rule tells that if a distribution is normal, then 68% of the data falls within 1 standard deviation, 95% fall within 2, and 99.7% fall within 3. Okay? In a distribution that's normal, I've got to stop recording for a second.